Welcome to the Explainer. Right at this very second, billions of gigabytes of data are quietly crisscrossing the globe, powering literally every tap, click, and scroll we make. But how often do we actually stop to think about the invisible traffic rules governing the whole shebang? I am absolutely thrilled you're here, because we're going to go on a really fascinating journey under the hood of the tech we use every single day. We're demystifying the unseen machinery, the core protocols of the internet, and breaking down exactly how your data moves across the planet in the blink of an eye. Here's our roadmap. First up, we'll settle the whole web versus the internet debate. Then, we'll track the evolution of the web. From there, we'll unpack how email actually works, followed by a look at telnet and file transfers. And finally, we'll wrap things up by exploring the e-commerce marketplace. Let's get to it.
Section 1. Web versus the Internet. Laying the foundation.
Okay, let's dive into this. Are the World Wide Web and the Internet actually the exact same thing? We use the words interchangeably all the time in casual conversation, right? But from a structural standpoint, they are completely distinct concepts. We got to clear this up before we go any further.
Think of it through this incredibly powerful analogy. The web is just one part of the internet, in the exact same way a library is just one part of a city. The internet is the city itself. It's the physical, global network of connected computers, servers, and miles of cables tracing all the way back to the ARPANET project in the 1960s. It's the raw infrastructure. The World Wide Web, on the other hand, which Tim Berners-Lee invented in 1989, is simply a massive collection of pages and information. It's the library, and you access that library by traveling over the internet's physical roads using your browser.
Section 2. Evolution of the web, from static to AI. Let's move to and see how this builds historically. Back in the 1990s, Web 1.0 was basically just a digital brochure. You looked, but you couldn't touch. It was entirely static websites where you could only consume information. Then, by the 2000s, Web 2.0 completely revolutionized things by introducing interactive and social platforms. Suddenly, you weren't just reading, you were posting, commenting, and sharing. The web came alive. Next came Web 3.0 in the 2010s, the semantic web. This is where data was structured so machines could actually understand it, which gave us those personalized, targeted experiences. And today, well, we're stepping into Web 4.0, which is an integrated, intelligent ecosystem deeply powered by artificial intelligence. Moving on to Section 3, How Email Works, the Relay Race.
To really understand the unseen workhorse protocols running quietly in the background, we need to look at a piece of tech born all the way back in the early 1970s. Email. When you hit send, an amazing relay race kicks off. Step 1, you write the message in your user agent. That's just a fancy technical term for your email app, like Gmail or Outlook. Step 2, your app hands the message to a local mail transfer agent, or MTA, using a protocol called SMTP. Step 3, a domain name server plays detective to locate the receiver's mail exchanger. Step 4, SMTP securely transfers the data between those two mail servers. And finally, Step 5, the receiver downloads it. Now here's where it impacts your daily life. If you use the IMAP protocol, a copy stays safely on the server. That's why you can read an email on your phone and still see it on your laptop later. But if you're using the older POP protocol, the email is usually deleted from the server once it's downloaded. It's literally exactly like taking the only physical copy of a letter out of a physical mailbox. Once it's gone, it's gone.
And this brilliantly illustrates that complex server routing. You can trace the exact journey, from the sender initiating the SMTP link, the data traveling right through the network clouds, reaching the centralized mail server, and finally being pulled down by the receiver via a POP or IMAP link. It's a totally intricate, perfectly choreographed digital handoff, and it's happening millions of times a second worldwide.
Section 4. Telnet and FTP, Remote Control and Files. So, the internet isn't just for sending messages. What if you need to directly control the computer halfway across the world? Well, to understand Telnet, we have to contrast a remote login with what you do every single day, a local login. A local login is simple. You sit at your keyboard, you type your password, and your keystrokes go straight through a terminal driver right into your operating system. A remote login, though, allows you to bypass geography entirely and log into a system thousands of miles away. And amazingly, Telnet originated in 1969. That is years before personal computers were even a concept for the general public.
When you compare the two architectures, a remote login has a really unique challenge. The distant operating system needs to believe you were sitting right in front of it. To solve this, Telnet uses a super clever trick called a pseudo-terminal driver. Basically, this piece of software intercepts your commands coming over the network and feeds them into the remote operating system, completely tricking it into thinking those characters are coming from a local, physical keyboard. It's brilliant.
But try to imagine the sheer challenge back then. How on earth do you get an Apple computer to talk to an IBM mainframe when they speak totally different languages? The ingenious answer was NVT, or Network Virtual Terminal. Before your keystrokes travel over the internet, Telnet translates them into NVT, which acts as a universal character set. The remote computer then receives this universal language and translates it back into its own local format. Discovering this invisible translation layer is just fascinating because it's exactly what made early global networking possible in the first place.
Now, if you want to move massive chunks of raw data, instead of just typing commands, you use FTP, File Transfer Protocol, which typically operates on port 21. FTP has two main modes. In an active connection, you ask for a file and the server actually initiates the data connection back to you. The problem with that? Well, modern firewalls are incredibly suspicious. They block random incoming connections because they usually think it's an attack. That's why passive FTP flips the script and acts as a clever workaround. In passive mode, the client initiates both the command channel and the data channel, smoothly bypassing those strict client-side firewalls.
You know, using FTP feels exactly like being a hacker in a movie. You're just typing raw commands into a black screen to pull data directly from a server. You type ls to list the files on the remote machine. You spot exactly what you want and type get to pull that single file down to your system. Need a whole batch of documents? Boom, you type mget to retrieve multiple files at once. It's raw, it's efficient, and honestly, it's incredibly satisfying to use.
Let's head into our final section, Section 5. The e-commerce marketplace, the digital economy. Now, what's really interesting about this slide is how it breaks down the digital economy into a remarkably complex matrix. It really is the ultimate combination of all these unseen technologies working together. We all know B2C, business to consumer, like buying a pair of shoes from an online store. But these internet protocols have enabled so much more than that. We have B2B, where businesses sell software to other businesses. There's C2C, like individuals selling vintage items to each other on auction sites. We've even got B2G, where businesses provide digital services to government portals, and G2C, government to consumer, like when you seamlessly pay your taxes or get a digital permit online. Literally every single sector of global society is now interlinked through this digital web. But we have to look at both sides of the coin. While e-commerce offers world-changing advantages like a completely global reach, significantly lower operational costs, and highly efficient paperless transactions, it also introduces some severe vulnerabilities. Because we aren't face-to-face, there's a distinct lack of physical quality assurance. We're highly dependent on continuous internet connectivity. And most critically, moving sensitive data over networks brings persistent, very real risks of security breaches, hacking, and fraud. It's a constant balancing act.
So the crucial point is this. From the early rigid days of ARPANET to the complex SMTP email relays and universal telnet translators, the internet has always been a constantly evolving organism. And as we transition into Web 4.0, injecting artificial intelligence directly into these foundational protocols, the unseen machinery is only getting smarter and faster. The internet is no longer just moving our files, it's actually learning from them. As Web 4.0 integrates AI into these protocols, how will this unseen machinery reshape the future of your digital footprint? Keep questioning the machinery you use every single day. Thank you so much for joining me, and I'll see you in the next explainer.